So let's divide integers. Let's start with the number 20 and divide that by 4. So most of us know the answer already is 5, but let's look at why the answer is 5. If I have 20 objects, yes, I'm going to draw them all out. 1, 2, 3, 4, 5. 1, 2, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20 objects here. If I divide them into 4 equal groups, because I'm dividing by 4, I can see that dividing them into 1, 2, 3, 4 groups, where each group is between the yellow lines, that what I have in each group is 5 objects. 1, 2, 3, 4, 5, and I have 5 in each group. So for that reason, 20 divided into 4 equal groups leaves groups with 5 elements in them. So I can do the exact same thing if I wanted to divide 20 by 5. Well, that we know equals 4, but let's look at why. If I were to divide 20 into 5 equal groups, and by doing it in this direction, I can separate the piles into 1, 2, 3, 4, 5 equally sized groups. What do I have inside of each group? Well, I'm looking between the blue lines, 1, 2, 3, 4 objects in each group, and so when I divide 20 into 5 equal groups, I'm left with 4. Just like when I divided 20 into 4 equal groups, I was left with 5. Well, let's look at the same situation here and divide 20 into 3 equal groups and see what happens. Well, let's start with our 20 again. Well, this was a bad start. You might have already seen that that was a bad idea. I know I want to divide into 3 equal groups, so what I'm looking to do is find how many, if I divide 20 into 3 equal groups, how many objects would be in each group. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so look at the problem here. I don't have an element in this last position, which means I really don't have 3 equally sized groups. So I can say that 20 does not divide by 3. Now I know you're there screaming, it does divide by 3, it does divide by 3, it's just a fraction or a decimal. So let me continue. It does not divide by 3 on the integers. Right? So what we're looking at doing in this unit is figuring out when I divide an integer by another integer, when can I get an integer? So I'm just looking for division that involves integers in all 3 positions. Okay, well, let's move on and do a couple of examples, because we have to bring positive and negative numbers in, because since we're dealing with integers, we know that integers involve all the positive numbers, 0, and all the negative numbers. So let's do some examples and just see what happens. So what if I divide negative 15 by 3? In this case, you can use either the fact that you know your multiplication tables and can work in reverse to get division, or if you want to pull out some objects and work with them, that's perfectly fine. You can put out 15 beans and then divide it into 3 equally sized pieces and see what you get. But remember, we're dealing with a negative number here, and multiplication, or excuse me, division is really the same as multiplication. In reverse, right? It's just in reverse. So remember, when we were multiplying with positive and negative numbers, we used the rule. So in this case, we want to use the rule. Do you remember the rule? It says go ahead and just do the division. So 15 divided by 3 into 3 equal piles leaves 5 elements in each pile. And the rule says every time you have a pair of negatives, they become positive. So this would be a 5, and I only have one negative, so this number has to stay negative. So the answer in this case would be -5. Let's do another example. Let's do 12 divided by -4. All right, so this is the same thing as we have one minus sign, so whatever happens, we know the answer is going to be negative, and then we can just do the integers or do the division on the integers. This is the same thing as the minus, or the opposite of 12 divided by 4, and that's just either because you know your multiplication tables or because you just did it with beans at home. That's -3. Do another example. Let's do 0 divided by 2. Yikes. Okay, well, 0 is a number. It's an integer. I'm allowed to use it, and I divide it into 2 equal pieces. So if I divide 0 into 2 equal pieces and eat 0 of it, I have 0. 0 divided into 2 is still just 0. And there's no plus or minus sign, so I don't have to worry about that. I wouldn't have to worry about it anyway with 0, but there you go. One more example. Let's do -32 divided by 8. All right, so I have one minus sign, so whatever happens, I know I'm going to have a negative, and then I just have to do the division on the integers. So I'm just going to do the division with the integers, and because there's only one minus sign, the answer is going to be negative. So this is a -32 divided by 8 is 4. So that would be your answer. All right, so let's do the same examples. We want to bring in some other notation. I'm going to do the exact same examples again, only I'm going to write them a little bit different. This time I'm going to write number 1, -15 divided by 3. So a fraction is really just division, right? This says take something, cut it into 3 equal pieces, and eat 15 of them. How many have you had? Notice I'm not dividing them into equal pieces, but I'm still having the same conversation. This would be buy one pizza, cut it into 3 equally sized pieces, and eat 15 of them. So we're not worried about the negative, because remember, the negative just tells us it's an operation to tell us to do the opposite. We're worried about the 15 divided by 3 right now. Well, if I buy a pizza, cut it into 3 equal pieces, and I eat 15 of them, well, if I eat all 3 of these, I'm going to need more in order to eat 15. So I cut another pizza into 3 equal pieces. Now I cut another pizza into 3 equal pieces. So I have 3, 6, 9. I'm not done. Another pizza into 3 equal pieces. And another one. Okay, so 3, 6, 9, 12, 15. I've now eaten 15 pieces of pizza. How many pizzas have I actually eaten? How many pizzas are in my stomach? I have 1, 2, 3, 4, 5 pizzas in my stomach. And then it's a minus because that's the operation that we're dealing with. And look what I had at the beginning. I had 5. So whether you divide it into 3 equal pieces by using objects, or whether you cut one object into 3 equal pieces, you're still going to end up in the same place. So this is a fraction. All right, that's the fraction form, and this is just the division form. Okay, let's highlight that because it's vocabulary, and vocabulary is so important in algebra. Okay, let's do number 2 in the same way. Number 2 is 12, this time divided by -4. Notice I'm using a horizontal line, not a diagonal line. Some of us have developed a sloppy habit of writing something like this that looks like 12 divided by 4. This is of no value in algebra. Do not do that. Use the universal don't do it sign around that. We want a horizontal line, and we want to put the numerator on top and the denominator on the bottom, and we want to put the minus wherever it lives. We can move it around later. So we know that there's only one minus sign, so whatever happens, we're going to end up with a negative number, and now I'm just going to deal with the integers. 12 divided by 4 equals negative 3. Again, I could say buy a pizza, cut it into 4 equal pieces, and eat 12 of them. How many pizzas did I have to buy in order to make that happen? Right there. 4, 8, 12. I had to buy 3 pizzas. The fact that it's negative just means that we're on the integers, and so you might have positives and negatives, but the operation of 12 divided by 4 is just pizzas. I'm getting a little bit hungry. All right, so 0 divided by 2. So you buy 0 pizzas, you cut them into 2. Well, obviously that's not even possible, so that just equals 0. 0 in the numerator is great. That equals 0. And then number 4 is negative 32 divided by 8. Answer, negative whatever 32 divided by 8 is. Running out of room here. And that is just negative 4. I get the same answer regardless of how I write the problem. So let's do just a little bit of evaluating expressions. Remember, that's when you have to plug values in for a variable. So still working with division, we want to evaluate 4 minus x divided by y squared. Yikes, that's a big ugly number, huh? When x equals 8 and y equals negative 2. Okay, so the first thing we have to do, so evaluating expressions just means that we're going to plug numbers in. So I'm going to plug 8 in wherever there's an x, and I'm going to plug negative 2 in, right, wherever there's a y. Let's keep my notation consistent. I'm going to plug negative 2 in whenever there's a y. So let's rewrite this. 4, this just equals 4 minus, well, remember that's where I'm going to make my trade, divided by, and this is where I'm going to make another trade, and I'm going to square whatever that is. So let's make the trade. Inside of this green parenthesis used to be an x, but now I'm going to make it an 8. And inside of this blue parenthesis used to be a y, but now I'm going to make it a minus 2. Now, why can I do that? Why is that okay for me to trade those numbers out? Well, because they're the same thing. This equals sign says that x equals 8. So if I have an x here and I put an x here, I'm actually still talking about exactly the same thing because they both are the same value. Equals means they have the same value. Now I can go ahead and do my work. Now I can't divide this yet because I have to do some subtraction in the numerator. So let's figure out 4 take away 8. So remember, this is addition subtraction. That's on the number line. The number line says start at 4 and take away 8. So minus 8 means move in the opposite direction. If I go 4 times to get to 0, 5, 6, 7, 8, where am I? I'm at negative 4. So that's a negative 4 over, now this squaring is the same thing as multiplication, right? That's negative 2 times negative 2, and that is the rule. We're going to use the rule. So this says 2 minuses makes a plus, and then just do the math, the arithmetic that was already there. So I'm going to have a positive answer, and 2 times 2 equals 4. Now I can finish the fraction. I have 1, it's division, so I've got to use the rule. I have 1 minus sign, and 4 divided by 4 equals 1. Okay, so that was an example. Let's do one more example of evaluating. So this would be example 1 and 2. We want to evaluate 10 minus x squared divided by y when x equals 8 and y equals -4. Okay, so let's look at what we're dealing with here. Whenever x equals 8, I want to plug, whenever I see an x, I want to plug in 8. So I'm going to put parentheses around the x. And then whenever I see a y, I'm going to want to trade for -4. So I'm going to put my parenthesis around the y. So now let's put our problem back together. 10 minus, that's a place for my substitution, squared divided by, I have another substitution to do. And now I can start filling values in. So the green parenthesis used to be an x, and I know 8 is exactly the same thing, so that's okay. The blue parenthesis used to be a y, and I know that -4 is exactly the same thing as y, so I can plug that in. And now I just have to go to work. Well, at this point I'm dealing with a 10 minus, 8 squared, right? Because this minus isn't part of the 8. I'm only going to square the number. So 10 take away 64, because that's 8 times 8, then divided by -4, so I still have a -4. Now, sometimes it's not as easy to work when the problem looks like that. Remember how easy it was to work when I had a fraction? So I want to go ahead and convert this into a fraction, because it just makes things so much easier to do, in my opinion. So I have 10 take away 64 divided by -4. Okay, well, that's the same thing as 10 take away, I don't know what this answer is going to be yet, but I do know, because there's only one minus sign in the fraction, that the answer is going to be a minus. See what just happened there? I have a minus sign here that has to be part of the problem, and then I have this minus sign inside of my fraction, and that one also has to be a part of the problem. So I have 10 minus minus. No big deal. We know what to do with that, right? In addition, we know what to do with the minus minus. So we're just going to leave it like that. And then I'm left with 64 divided by 4. Well, that's just 10. We know that minus minus, when they're written side by side like that, becomes a plus. Because on the number line, if I'm at 10, going the right direction, minus says turn around, another minus says turn back around, it just turns me back to plus again. I'm right where I started. So minus minus becomes a plus, and then 64 divided by 4, well, that's just 16. So 10 plus 16 equals, now this is addition subtraction, so I'm still on the number line, right? I'm at 10 going the right direction, and I go 16 more, so I'm at 26. And the answer is positive because I went 26 more in the positive direction on the number line.